For the past 2 or 3 weeks, my ram pump keeps stopping. It's late summer, almost fall. This happens every year. And I believe the problem is that my source is not producing as much water as it has for the past 5 months. I've got a 1-inch ram pump. Had the same problem last year when I was running 2 3/4-inch ram pumps. But anyhow, this video is a long one. Over the past 2 or 3 weeks, I've probably made close to 100 little clips. I'm going to try and edit most of it out. And I'm going to put a bunch of stuff in there that, you know, an expert doesn't care about. But if you're new to ram pumps, you may see something that gives you an idea of how to fine-tune yours if your ram pump keeps stopping. I feel like I'm going to eat crow today. Seth Johnson's going to love this. Seth from Land to House. He's the guy who really got me interested in a ram pump. And that man probably knows 100 times more than I do about them. But he prefers the horizontal style, and I prefer the vertical style for reasons, you know. In my case, I don't have to pump very high, and I love the idea that the vertical pump starts so easy. Seth, he has a different situation. He's in the mountainous part of North Carolina. I'm in the Piedmont. But anyhow, I'm going to give you a spoiler right now, so you don't have to watch a big long video. My solution with limited water was to go to a horizontal type ram pump design that would put my pressure tank lower towards the ground, and everything worked out okay that way. I'm only getting about half as much water as I normally get when things are right, but at least with the horizontal style, it's not shutting off every day. So I'm going to go ahead and just tell you that's how I had to do it. If you want to go through the painful process of how I arrived at that, just keep watching. It's late summer here in North Carolina, and this time of year I often have problems with my ram pump just shutting off. And I believe it's because the water table is just so low this time of year. Usually, well, hopefully, we'll get remnants of a couple of hurricanes and things will get back to normal. But when you've got temperatures, over 95 degrees, days on end, no rain, the soil dries out fast. And so even if you get a rain shower, it may not make it down very deep. The top layer will just absorb that rain like a sponge. So I'm going to go down here to the creek and show you where I'm getting my water from, and little things I've done to tweak my ram pump to accommodate this low water table. And some of it worked, some of it didn't. And I can show you exactly what my problem is, but I've been trying to fix everything around it instead of dealing with the main problem. I've got a 1-inch drive pipe on my ram pump. It's basically a 1-inch ram pump. And usually up here I get 20 to 25 gallons per hour outflow. Right now I'm only getting about 10. That's because I've had to modify my ram pump situation. But you think about that, if you're getting 20 gallons per hour into your reservoir, these ram pumps are only about 10% efficient. That means you're putting 200 gallons or more per hour into that ram pump. To get 20 out, you got to put 200 in, at least. It sort of looks like a creek, doesn't it? I mean, it's a ditch and it's got water in it and the water is moving. but if you look at this on a Google map, it has no name. This creek doesn't really become a creek until you go downstream about a quarter of a mile. That's where it meets a real creek. This is just an intermittent ditch that about every 100 feet between here and the highway has little ditches that run into it. So if we get any rain, this thing can go from being so shallow you don't need boots to being 6 or 8 feet deep in this little intermittent creek. But let me go down and show you where I've got my ram pump intake. Can you see how much water is flowing across the top of this rock? I don't really know how to estimate it, but let's say it's 10 to 20 gallons per minute. Pretty significant amount. At least 10 gallons per minute. Obviously, the solution would be to seal this up a little bit better to where I'm not losing so much water. All that you see in that crack is water that's not going into my pump. But that's easier said than done. There's the shelf that's underneath this pool is irregular, and there are pathways underneath the shelf rock for that water to come out. So for me to really do this thing right, I'd have to put a big liner in here. And that's something I've been trying to avoid. Maybe we'll get a hurricane in the next week or two. Right now I'm at least getting 10 gallons an hour up at the house. But let me come down here and talk about what I've had to do. I have a 1-inch dry pipe. And I would say it's probably close to 20 feet long, but it's not a straight shot. I've had to zigzag it around these rocks to avoid having areas where I could get a bubble of air in the line. And I'm sure that makes it less efficient, zigzagging like that. But even that way, I'm still getting about 4 gallons per minute coming through this dry pipe. So I'm satisfied with that. That will run a 1-inch ram pump. The problem is if I'm taking 4 gallons a minute, and you think about that, that's over, what is that per 6 times 60? 240 gallons per hour out of this little pool. That's thousands. Close to, that's 5,000 gallons per day that's going through my pipe. And all it has to do is just sink down an inch or two to where I'm not, to where I get a gulp of air into my dry pipe. And then the pump will shut off. And then immediately this thing will fill back up. This is not good. My ram pump is not pumping. I don't know why. It's shut off at least 6 or 7 times in the past 10 days or so. The last time it did that, I just swapped out my check valves. I've got 2 check valves that are identical 1-inch check valves. One, the flow of water goes up, and on the other one, the flow of water goes down. So this is what I call a vertical ram pump. And I think the waste valve is the one that gets the worst abuse. It slams shut every second. At one point I did the math on that. 60 times a minute, 3,600 times an hour. I think it comes up to over 2 million cycles per month. I've had these things down here about 3 months, but like I said, about a month ago, I sort of swapped them out, reversed them. And I don't see any coon tracks down here today. All I see is my boot prints from where I was here yesterday. Okay, we'll get over here and take a closer look at the situation. Try and figure out why this pump would turn completely off. I have a 1-inch drive pipe, and I would say it's probably close to 20 feet long, but it's not a straight shot. I've had to zigzag it around these rocks to avoid having areas where I could get a bubble of air in the line. And I'm sure that makes it less efficient, zigzagging like that. But even that way, I'm still getting about 4 gallons per minute coming through this drive pipe. So I'm satisfied with that. That will run a 1-inch ram pump. The problem is if I'm taking 4 gallons a minute, and you think about that, that's over, what is that, per 6 times 60? 240 gallons per hour out of this little pool. That's thousands. Close to, that's 5,000 gallons per day that's going through my pipe. And all it has to do is just sink down an inch or two to where I'm not, you know, to where I get a gulp of air into my drive pipe, and then the pump will shut off, and then immediately this thing will fill back up. I can see that my spring pool is completely full. It's flowing over my sandbags over here to the left. Last year I had 2 3/4-inch ram pumps that I was siphoning water out of that spring pool. And late in the season, you know, long about August or early September, they kept shutting off, and I ended up having to take one of them down. I hated to do that because it was just the time of year where I was going to reseed my yard and everything. But with 1 3/4-inch pump, I was only getting 10 to 12 gallons of water per hour up at the house. With 2 of them, I could get close to 25 gallons. So this year, I just used a 1-inch pump, and I'm not siphoning it. We'll go up and take a look at that intake, see if it's blocked or something. But with this, I've been getting 25 to 30 gallons an hour at the house. I think the first thing we're going to try is I'm going to remove this 1-inch check valve and replace it with a 3/4-inch check valve. And that's something you can do, or at least something I've been able to do with this vertical style ram pump. I was not able to do it with the linear or the horizontal type ram pump for some reason. But it's pretty simple. This elbow has a 1-inch female pipe thread in it, so I'm going to need an adapter that goes from 1-inch to 3/4-inch. This nipple. We'll do that. And then put the 3/4-inch on here. Now let's turn the water on and see what happens. Okay, this, like I said, this kind of ram pump usually starts pretty quick, even though this thing's been shut off. Shouldn't take very much to get it started. One push. Okay, we'll see how this goes. I'll go up to the house and take a measurement to see what kind of water flow I've got with this 3/4-inch check valve. I'm guessing it's going to be 10 to 12, which is not satisfactory to me, but it's better than nothing. And I'll get a new 1-inch check valve to put back down here. All right, we're up here at the little pond, my irrigation pond, my collection pond, and we're going to see how much water is coming out of this delivery pipe now that we've replaced my 1-inch check valve with a 3/4-inch waste valve. And that 3/4 incher is a used valve. I can tell you right now, I'm not getting very much water out of here. But I pretty much wanted to see if it might have been air getting into my line or an animal messing with it or what. But anyhow, we're going to see what kind of flow we got here. If you ever want to check your flow, I recommend getting a 32-ounce cup. That's 1 quart. There's 4 quarts to a gallon. Get an analog clock and label it the way I have mine. At the 12 o'clock position, 15. This stands for 15 gallons. 60, 30, and 20. In other words, time how long it takes to fill up a 32-ounce cup. If you can fill up that 32-ounce cup in 15 seconds, you're getting 60 gallons an hour. If it takes 30 seconds, you're getting 30 gallons an hour. If it takes 45 seconds, you're getting 20 gallons an hour. And if it takes you a full minute, that's 15 gallons an hour. So, here we go. We'll see what we're getting. I don't even think I'm going to get 15 gallons an hour. I probably should have started when that second hand was on the 12 to make it more simple for the people watching this. But yeah, we'll just start over. I'll wait till it gets on the 12 so I don't confuse anybody about what I'm saying on how to check your flow rate. Now, by the way, I'm close to 800 feet from my pump. I got a crazy situation where my pump flows downhill half the way and then uphill the second half. Okay, here we go right now. Yeah, I don't even think we're going to get 10 gallons an hour out of this. There's 4 quarts to a gallon. So if it takes a full minute to fill up this 32-ounce cup, that means it would take 4 minutes to fill it up 4 times. In other words, it'd take 4 minutes to make a gallon, and 4 goes into 60 minutes 15 times. So if it only took 1 minute to fill this cup up, you'd be getting 15 gallons an hour. If you can fill this cup up in 30 seconds, that's a gallon every 2 minutes. That's 30 gallons an hour. All right, we're coming up on the 1 minute mark here and still haven't got the cup full. This is not going to be very good. All right, there it is. So it took a minute, close to a minute and 10 seconds to get a quart. That means it would take 4 minutes and 40 seconds to get a gallon. That's pretty close to 5 minutes per gallon. So we're getting about 12 gallons a minute here. That's not very good. But at least this tells me that the problem with my pump probably lies somewhere between the pump itself and the intake. Maybe a leak in the drive pipe, maybe just a low intake. It's been hot. So anyhow, I'm going to let this go till tomorrow. I ordered me another, I ordered some more check valves. And tomorrow we'll go back down to the creek and install some new check valves and see what a difference that makes. This is not good. Here we are the next day after I installed that 3/4 inch check valve on my pump, and the water has quit pumping. I'm really shocked. I was thinking that maybe I was drawing too much water out of that spring pool, and switching to a smaller check valve might not drain it down to the point it starts sucking air. Just gauging by the amount of water in my pool, I would say this happened sometime overnight. We'll go back down to the creek and look around, see if there's any coon tracks around my pump. They might be using that as their own little wash stand. This thing's been clicking for about 15 minutes, and then without warning and without any obvious reason, it just shut off. You know, a lot of times if I have air in my dry pipe, I'll hear it gurgle or spit and sputter, but it just stopped. So we'll give it another round here. But while I'm looking at this, here's a good tip for you. You can get these manifolds for about 11 or 12 bucks at Lowe's for your delivery. And I've got a short hose here, I think 50 or 75 foot hose, that just goes right up the hill here to my ladder. I don't know if you can see that, but I got water flowing out of that pipe, that garden hose. So that this is an easy way to test your system, because my pool is close to 800 feet from here. And that's a lot of walking back and forth. Now eventually I will do a test at my pool, but for now, especially if I'm experimenting with the ram pump design, it really makes it easy to just walk up that ladder and take a measurement. You can also attach a pressure gauge to one of these outlets. There's a lot of things you can do. You can release the pressure out of the pressure tank, etc. Well, my intake filters are clean. This is a crazy looking drive pipe, but I had to go zigzag because the rock has too many bubbles in it. That's the only way I could get my drive pipe to go down to the pump, downhill all the way. Checked all those joints, none of them are leaking. So we'll go down here and take it loose from the pump and see if we can measure the flow. I've disconnected the ram pump from the drive pipe. I really don't see any leaks in the drive pipe. I've got a 5-quart pot here, and I'm hoping to get somewhere around 4 gallons a minute. So if I can fill that 5-quart pot up in less than 20 seconds, that will be 15 quarts. There's 16 quarts in 4 gallons, so 20 seconds or less is what I'm aiming for. Here we go. I didn't bring my clock down here. I'll just have to count it out. Y'all can count it for me. Ready, set, go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, it was only about 17 seconds where I was getting, I'm getting 4 gallons a minute. I wish I was getting 8, but that's what I got, 4 gallons a minute. And that should be enough to run this 1-inch ram pump. I mean, it's been running it all year, just until recently. There's been no problem at all. This will give you a different look at my ram pump. It's such a simple thing. The water would be coming into here. This is a 1-inch T, and it would flow down here to this elbow, and this is my check valve, my waste valve, 1 inch. All this is 1 inch. Then I have another check valve here, and this goes up to my pressure tank. I'm going from 1 inch to 3/4 inch here with an adapter. So I've got a 3/4 inch hole on my pressure tank, and I'm reducing from 1 inch to 3/4 inch here on my delivery line. Everything else is 1 inch. Real simple, starts up great, and until this month, it never shuts off. Alright, I'm going to go ahead and put a brand new check valve here, put this thing back together, see what happens. I have had problems in the past with the pump not working, especially when I had one of the linear type ram pumps down here. I just did not have enough back pressure to keep it going. This is a strange situation. This creek only changes about a foot every, my God, less than a foot every 100 feet. If that, maybe just a couple of inches every 100 feet, but it goes downhill from here down creek 350, 400 feet, and then it makes a right turn and I go uphill 300 or 400 feet. So I really don't have a lot of back pressure until this water in the delivery pipe gets more than 300 feet from here, almost up to my retention pond there, my irrigation pond. But this has always been a slow system because I've got less than 3 feet of head here, especially with my intake being submerged about 6 or 8 inches up there in the pool. And I figure my total rise going up to the irrigation pond is maybe 12, 14 feet at the most. So that's not much back pressure. Okay, well, it seems to be doing okay for now. Of course, by the time I walk the 800 feet back to the house, that's when it decided to shut off. We'll stay in touch. Appreciate you watching. Back up at the house now. We've just installed 2 new 1-inch check valves on the ram pump. Yesterday with the 3/4 inch, it took 1 minute and 10 seconds to get 32 ounces. I can look at this and tell you this is going to be a lot better. Let's see here, ready, go. Yeah, and this is with the delivery valve only about 60% open. And I do have that that faulty connection down there. It needs to be glued back together. But I'm kind of tired right now, so I'm going to give this a day. If it don't quit, then I'll assume that the problem was the check valves, and I'll go down there and get everything fine-tuned. If it turns off, I don't know. I might have to reinstall my dry pipe. Well, that's 45 seconds. So this is not doing that great, but it's a lot better than yesterday. And 1 minute to get 32 ounces. That's 15 gallons an hour. It looks better than that, but it's not. Okay. Well, hopefully by this evening this pool will be full. I can go ahead and irrigate. We've had a dry week. I'll keep you updated. I'll let you know how we finish this project.